All right, guys, so I wanted to look at this example from our notes. Previously, we had done an example where we had 2 red cubes and 1 green cube all in a box, and you can see them here. And we went through and we found the probabilities for each spot on the tree if the cubes had been replaced. So I drew a cube and then I replaced it after the first draw. Now, this is going to be slightly different because now I'm saying, now draw from the same box twice, but do not replace the first ball. We did cubes because it makes more sense. Do not replace the first one. So, here I have an example of my pretend box. We'll move this thing over here. I've got my pretend box. And I've got 2 red cubes and 1 green cube, slightly different than the one in our notes, but I just changed it so that we could follow with our Unifix cubes in person. So in my box, on the first draw, I have a red or a green. Those are the only 2 options I have. So on the first draw, I haven't actually done anything. This is what's inside the box. The probability of red is going to be 2 out of a total of 3. So I'm going to write that on my tree. The probability of green is going to be 1 out of a total of 3. And that's the first draw. Now on the second draw, whatever I have taken out of the box, I am not going to replace it. So what this says is you drew on the first draw a red cube. So I drew a red cube. Let me get the whole thing. And we'll just hide it back there. I did not replace it. So I took that red cube out. Now left in the box, I have 1 red. So the probability is 1 out of 2. And I have 1 green. So the probability is 1 out of 2. Now this next one says, all right, you have, so I have on my first draw, I drew a green cube. So let's write that. On first draw, removed a green cube. All right, so now what I'm looking at is I have taken out a green cube. So I drew out that green cube. Now what's left in my box is this. I have 2 out of 2 that are red and 0 out of 2 that are green, because I drew out that green cube and I did not put it back. Let's go back to the directions. It says, but this time do not replace the first cube. So now we learned that there is a shortcut that says you can find the probabilities by multiplying all of the probabilities along the tree. So if I'm looking for the outcome red, 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 the probability of that is going to be multiplying those 2 outcomes. 2/3 times 1/2. And think back to your 11 days. Multiply straight across the top. 2 times 1 gives me 2. Straight across the bottom. 2 times 3 gives me 6. And then I do want to reduce that thing down to 1/3. All right, now the next one, red, green. So outcome is a red and then a green. To find the probability, I'm going to multiply red, 2/3, times green, 1/2. 2/3 times 1/2. Multiply straight across the top, straight across the bottom, and simplify. Make sure you do simplify those fractions. I don't care if you just simplified at the very end, but you do make sure that you simplify before you give out your final answer. All right, so for the next line of the tree, green, then red, I'm going to multiply those probabilities. So green is 1/3, red is 2/2 or 2/2. So I've got green, then red. All right, green is 1/3 times red, 2/2. Okay, multiply straight across the top, 2/6, or again, 1/3. And then the last one, green, green, multiply those probabilities. 1/3 times 0/2 is going to give me 0/6, or 0. Let me change those colors. 0/6, or 0. So all of these are now your probabilities for each specific outcome. Now, what I may do is then I may ask specific questions. So it may be something as straightforward as find the probability of a green then a red. So if it says that, probability of green then red, I'm going right here to that line. And then the probability of green then red would be 1/3. But it may be something a little more complex, like probability of exactly one green. Exactly one. So not 2, not 0. Exactly one green is going to be this scenario, or that scenario. So exactly one green would be the probability of red, green, or plus green, red. Those are the two ways to get just exactly one green. And I have those two probabilities, 1/3 plus 1/3. Let me write this underneath so it's a little bit clearer. 1/3 plus 1/3. Now with these, when I'm adding fractions, I keep the common denominator, add up the numerators, and that's going to give me the probability overall of exactly green. So there's several practice types of problems we'll do later in the notes and then in your homework, but I wanted you to at least see how we go about making the tree diagram, how we can use the probabilities on the tree diagram to find each individual probability. Now, you won't have to write all of these out necessarily. This is just to show you how you find all of those probabilities.